Well, hey everybody, it's Chuck. Welcome in the barn shed. So I told you I was gonna make oxalic acid strips and sponges. It's raining a little bit outside and I'm gonna do it right now. But at the very beginning of this video, I wanna just say this is not a recipe video. And the reason is because I'm confusing the recipe and I don't want to confuse you. I have a previous extended release oxalic acid video. Please just search my YouTube channel for extended release. I'll try to put it in the description, maybe even the upper right hand corner of your video. I'll put a little card to remind you. Go there for the proportions and recipes because that's the basics of a batch, right? But I'm a little bit more advanced now and this video could confuse you with my proportions. So I'm gonna try to not tell you the proportions I'm doing because I'm doing the same thing I did before. I have a spreadsheet I've created and a lot of people ask if they can borrow my spreadsheets. And I say, it's not, I usually am willing to loan somebody my spreadsheet, but when I do, I'm like, listen, I don't have time to explain in every single cell and how the formulas work. You know, here it is, use it, copy it, but I can't teach individuals how to use my math. I create some crazy spreadsheets sometimes and they help me, but I'd like you to just go back and treat this like a recipe in the kitchen and do your proportions right and measure it out and do the right safety protocols to do this safely. So I'm going to do two different things today. I'm gonna make sorry, I just came out of camera, the extended release strips, and I've already got all these cut up. I ended up cutting up 77, and I did 77 because of the amount of oxalic acid I had and the number I wanted, and so this is not a batch, this is like a batch and a half. But with the certain number of strips, I've got the formula worked out to the exact amount of oxalic acid I need, and glycerin I need, and water I need to get the correct proportions of oxalic acid in each strip. And just to kind of remind you, what the goal is, and I'm looking at my sheet here, is to get 10.2 grams of oxalic acid per strip. This is a wash tub. I've learned to use a wash tub to let them soak in. And one important thing is don't make them too tight. If you rubber band these together, they don't absorb as much. So give them a little bit of breathing room in your bucket. So this is where we're gonna pour our OA when we are done making the formula. And the second batch I'm gonna make is I'm gonna make a batch of sponges. And these sponges are cut up and I've got the proportions mixed out. Matter of fact, I can't even make as many sponges as I cut because I ran out of OA. So I'm getting my proportions right to use up every drop of OA I have in this bucket. And just a reminder, in a half of a Swedish sponge, we are going for 25 grams of OA per sponge. So that will be done in here. So the way I do this, and I'm gonna do the strips first, and I'll just put my safety glasses on. I'm a pilot, my eyes are important to me. Splashing acid solution in your eyes isn't good. But one of the most important things to do before you mess with your acid, especially if you're boiling and splashing, is make up a batch of, this is just baking soda I buy in bulk, a little bit of a bucket or bowl. And this is not precise. This is a couple tablespoons, maybe in a couple cups of water. And this is just a base solution that if anything splashes and I need to wipe anything off, or even my cleanup at the end, this will be what I wipe up with. This is just an instant neutralizer of OA. Okay, so I've got my base, my safety solution done. And the way I do this, I've got an induction stovetop here, and I've already got water boiling. So I use a double boiler method. I've got a candy thermometer. This is, I would say, extra. But the important thing about the candy thermometer is you don't want your OA solution and your solution in glycerin, fogging up a little bit, your solution to get hotter than 140 to 160. You need to kind of keep it in that range because Randy Oliver has taught us a little bit about how if it gets too hot, it'll create some esters and it'll kind of start to come out of the actual chemical bond that we want. But the first thing we need to do, and I'm gonna go ahead and get my portion, is I need to heat up some glycerin. So I've got a beaker here, and this is my glycerin I use. I got this off Amazon. It's just vegetable glycerin. And I am gonna measure out the number of milliliters of glycerin I need in this beaker. It happens to be 785. And these ratios, and one important, some people say, why do you use glycerin and water? And the reason we use glycerin and water is because we're putting so much OA in the solution that the water helps it go into solution without, there's so much of the chemical going in there, it needs help going into solution, so the water is diluting it a little bit. And I was pausing there because I realized I'm making a bigger batch than I normally do, and I'm not 100% sure that my batch is gonna all fit into this bowl, so I'm gonna have to, I'll be right back. I'm gonna have to change, I need a bigger pot. Okay, I'm back with you. So I basically am not gonna be able to do a double boiler today because I'm making a larger batch than will fit into my pot. So I'm having to just use the regular old pot on the bottom, and I'll have to watch my temperature as it heats up, which is what the candy thermometer will be good for. A continuous stirring motion, and to not let it get too hot. I'll even take a couple of knots off of that. Okay, and then I need my water. So the water solution is essentially the exact same. I typically pour it in the same exact beaker so I can kind of clean the beaker out a little bit too. And half of the water is going to go in now. So I'm going to heat this up, essentially. And the reason I'm doing half the water is a little bit of a trick I've got here in a minute. And I'm already getting to a good temperature. So I'm trying to just slowly stir this, get it up to temperature, and I'll throttle back my induction once I get up there. And we're already at 125, 130-ish on the thermometer. This is the same thermometer I use for my when I make fondant, when you're heating up sugar up to those high temperatures. This temperature is actually on the low end of its scale a little bit. I'm gonna throttle that back a little bit. All right, we are in the 130 range. And after we heat up our glycerin, half the water to a beaker, twice the used candy thermometer, add oxalic acid. So I've already got my oxalic acid here, and this is going straight into the heated solution. And if you notice, I always have a little bit of powder in the bottom of this, which is why I've got the other half of the water I use to pour into this jar to kind of swish around to get all of my OA out. The OA is the magic ingredient that essentially we're trying to get most precise into solution here, and continuously stirring until this goes into solution. I'm going to bring this over just a little bit, and maybe you can even see a little bit more of what I'm doing. Okay, I'm back. So we have got our solution completely mixed up. I can't see any more OA. It's taken on a nice clear consistency. Sometimes you have to kind of mash the little clumps of OA that just are the last little bits to go into solution. And I'm right now at about 135 to 140 degrees, so I have not exceeded my threshold temperature. But there's no need to get any hotter. Once you have it in solution, you don't need to get it any hotter. So that's the main goal. So once it gets clear, I think that is your best signal. And now, essentially, and I'm going to try to find a way to show you how I do this without making a mess. So I'm going to go ahead and take this off, and I'm taking it off at 140. And the beauty of induction, it's not hot. And here is our strips again. And I'll try to just get a little bit closer for this final shot. And the temperature is still below 150. So this is where you might splash. So just take this slow. Slow and easy. The entire solution is designed to soak into that amount. And this is where the baking soda rag is nice, because you know that lip has a little bit. And now I'm essentially gonna just massage this in here. This is where the gloves are important. All of this solution should get absorbed if the formula is right. And of course they're gonna swell a little bit, and that's okay. They're designed to swell. And obviously you don't want them to float it. See those, but as the bubbles come out, you know it's all absorbing. And the last little bit of this at the very bottom, it'll wick up into this cardboard and should be absorbed completely. It's not absorbing like a sponge. It's kind of displacing air, I guess you could say. Very, very slowly, but I do want to keep them all face down on their sides on the bottom to absorb it as easily as possible. Okay, so this is how I'm going to leave this batch. They're still soaking in, but the liquid is in there, and now it's just going to rest into that safe bucket. So now we're going to do our sponges. Okay, same methodology, but because I need to start touching some things, I'm going to kind of make sure I baking soda myself down. And the sponges do not need the water solution. Adding the water to the cardboard, the water evaporates and is no longer going to be in there. So it's really not an ingredient as much as it is a solution to get it into that tighter chipboard. These sponges are going to absorb so much, the glycerin and OA by itself is going to be enough. So basically I'm just taking 800 grams of oxalic acid, and this is going to be for 32 sponges, 800 grams of oxalic acid, and essentially the same amount of glycerin. I believe it's going to be 800 milliliters. Yep, 800 and 800. So I am just going to measure the bag and assume the bag has a little bit of tear weight to it. I believe I measured this out already. Yep, it's just a shy over 800, so I'm going to say the bag weighs 5 grams, and that is how that's going to work. So I need to use the full bag, and I need 800 mils of glycerin. All right, let me go ahead and do that. Actually, mils, I'm not weighing that. All right, and this is going back on, and I'm heating this back up. A little bit of water isn't going to hurt because, like I said, it's evaporating out, but it's not required for the solution. This is just to clean my jar. Theoretically, a little bit of water is going to go in a solution with the glycerin, but it will evaporate back out. All right, so now we're going to heat that back up, and my thermometer is just in there, and it's just coming up to 90 degrees. Okay, we are up to temperature now. We're nice and warm, and here goes the full bag. Well, the 800 grams of OA to pair with the 800 mils of glycerin. Okay, we are back and we are in solution now, and we're right at 145. A little bit hotter but without the water to get it into solution, which makes sense, right? We didn't have quite the same solution. So I'm just gonna pull that off, set that aside, and show you how we're gonna do this. Now this will absorb this mixture much, much easier, and because sponges are designed to absorb. But the same thing, taking it easy so we don't splatter too much. And then just moving the solution around so it will absorb all of that OA into each sponge equally. With your gloves on, you can flip over your sponges and make sure you kind of get them both sides equally. Whew. 150 degrees. Solution's almost gone here. Yep, solution is all gone, which is exactly what you expect with the sponges. They are just going to absorb all of that glycerin up. Now, looking in the center of some of these sponges, you might see some dry spots. With the sponges, guess what? You can just kind of squeeze them to get it all mixed in and reabsorb. All right, so there's our sponges. They're all the liquid is absorbed up. Let me go ahead and clean up with my baking soda. I can even hear it sizzling, neutralizing that acid on my gloves. But I want to show you at the very end of this video how the chipboard strips are going. So you can see with the chipboard strips, I still have a little bit of glycerin water solution here. That is what I'm talking about when I'm absorbing. There's a chance I have just a few too many strips in here. This was 77. So this bucket might need 70, something like that, to give a little bit of more room. Because what happens is these chipboards are kind of compacted together and they're not loose and able to kind of separate and have the liquid go all the way around them. I could have two buckets basically, and I could share the load. But you can't leave this overnight, because what's going to happen is once this glycerin solution cools down, it's going to kind of turn into a little bit of a gel with the glycerin, right? Right now we're in a thin solution with the glycerin and water, but overnight it's going to congeal. So actually it's going to congeal in like an hour or two. So you really don't have like a set it and forget it. You need to kind of get as much into the solution as you possibly can now, before it cools down all the way. And I'm even squeezing them a little bit to get some bubbles to kind of come out, like I was with the sponges. But I would say I've gotten almost 95, 97% of the solution in there, which means I should have enough OA in each of these strips. If some of that solution didn't go in, I would just have to sort of say, okay, well, this strip has 10 grams of oxalic acid per strip instead of 10.2, right? Randy's formula was created to maximize the amount of OA that these substrates, and this one being chipboard, could hold, right? Each type of substrate can only hold so much material. And we've kind of formulated this to where this is the right recipe. In any case, here I am finishing up. This was not intended to be a proportions video. This is a technique video, talking a little bit about my safety techniques and how I do this. Please do refer to that original video on where I use, measurements and a batch that you can copy down and do for yourself. All of this comes from Randy Oliver's website. I didn't invent any of this other than perhaps the techniques of how I put it together. It's all about the oxalic acid, getting it into the hive and into the brood nest. In any case, thanks for watching. Hope you guys enjoyed this. Have a great day.